I am from CSPIT department of Charusat University. My ID number is 24C115. Today I am giving a video presentation on the topic of inside the mind of the self-driving cars, which is an in-depth exploration on the autonomous vehicle technologies. Guys, the 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 before we start our topic, we should also know about what is the self-driving car. The self-driving car is nothing but a vehicle-equipped advanced system in which a vehicle-equipped advanced system that allow it to navigate without human inputs, and this includes AI sensors and control mechanisms that help the vehicles in taking the real-time decisions also. The this autonomous system has different levels. First, it's range from the level 0, which works car manual. Which has no automation, means a user has to be drive the car manually, and up to the highest level of 5, which fully automation, where the user has to only sit on the cars. The cars will all do the all functions, and just like an human are driving the car. There are the 5 key systems works behind and the autonomous driving system, self-driving system. First is perception system, second is localization system, third is AI perception, and fourth is path planning, and fifth is control system. So let us discuss in brief about the system. First is the perception system. Perception system is the subsystem of autonomous vehicle that enables it to use a vehicle to understand the environment around it. It also processes the data from the various sensors like camera, LiDAR, and radars to detect and classify and track the detect, classify and track the object, lane marking and road signs, traffic lights, and many more. There are the various key functions of perceptions like object detection and classification. It identifies the car, pedestrian, bicycles, animals, and road barriers, and etc. It tracks the object position and velocity of the dynamic object over the time, which is important for the prediction of the object movement and to prevent it from the collision. It also helps in the road lane marking and detection, and it detects the lane boundary, road edges, and stop line and crossovers. It also detects and also follows the traffic signal, helpful for the following the traffic signals by the for the car, and the traffic sign recognitions. Also, it also helps the car to analyze is the 3D object and its shape nearby, and the shape and dimension of the object nearby it. Now these sensors are the major part of the autonomous driving car. It is the autonomous driving cars has various sensors inside which help it to drive itself like an human. First sensor is infrared sensor, or it is also known as thermal sensors. It detects the infrared radiations emitted by the object. Generally, it's used for ADAS and an autonomous driving system. Mostly, it widely used of these sensors are in a night vision and pedestrian and animal detection in low light. Right, and it is very most advantage is best is the it can work in the darkness also. Second is LiDAR. LiDAR is the one of the most and important sensor of the system of the self-driving car technology. LiDAR is a crucial technology in the self-driving cars. Provides detailed 3D map environment and around the vehicle. It uses the laser pulses to measure the distance to the object, enabling the car to see and navigate effectively even in the challenging conditions also. How let us talk how the LiDAR works. First, LiDAR emits the pulses which is bounced back to the objects in the surrounding environment. The time it takes for the for the LiDAR pulses to return the sensor is measured, allowing the car to calculate the distance to the each object. And by analyzing the thousands of pulses per second, LiDAR creates a 3D point cloud with a detailed representation of the environment. On this point cloud, data is used to identify and track the objects and predict their movements and plan the car paths. There are the various benefits of LiDAR in self-driving car. First is the precise distance measurement. It provides the highly accurate depth perception and allowing the car to know the distance to the object. Right, it has enhanced permissions. It has it complements other sensors like camera and radar, providing to more complete and reliable picture of the surrounding. It also helps in the real-time object tracking and navigation in the challenging conditions also. It is very expensive, but with the evolution of technology, it can be affordable by doing the mass production also. It can integrate with various sensors and algorithms answer for the more computation power and processing capabilities also. LiDAR can generate massive amount of data which needs to be processed efficiently and accurate to enable real-time decisions. This is the video which uh, says that illustrate that how LiDAR works. See the video. The self-driving car is generating the pulses, and this pulses are bounced back to the surrounding cars and makes a 3D point data cloud. And this data cloud data will help it and to take the decisions in this type of systems. Now camera. Generally, we all notice how the camera uses generally is works as an eye for a self-driving car. It captures the visual images similar to the human eyes and provide RGB data and helpful for the land detection, sign recognition, and pedestrian and vehicle detection and visual odometry. Its advantages is it provides rich information and low cost. Is very low cost. But its illusion is that it performs drops in the low light and adverts. GPS, the Global Position System. It uses the satellite signals to determine the geographical location of the self-driving cars, which helps it to generate a 3D map of the route and helps into the route planning also. It advances it can be globally used and it's very issue in the urban area means that if there is a very more traffic, it can do not work more efficiently. IMU, Initial Measurement Unit. Generally, this unit combines the accelerometer and gyroscope meter to measure the acceleration and orientation. It helps in the motion tracking, pitch and roll and yaw. It is very fast and precise. Ultrasonic sensors. Ultrasonic sensors are those sensors it emits ultrasonic waves and measures the echo to detect the nearby object. It generally helpful for the parking system and low speed navigation and proximity alerts. It is very low cost and effective for close proximity detection. Radar. It is also one of the most important sensor used in the self-driving cars. It transmits the radio waves and measures the delay in the Doppler shift for the distance, speed, long range detection, and adaptive cruise control, collision avoidance. Works in the poor weather conditions also for the velocity measurement. Second, localization, knowing the vehicle position. It combines the various GPS, IMUs, and HD maps, which ensures the precise location even without a GPS and help for the without safe navigation and lane positioning. AI and perception. The computer visions identify the objects. LiDAR detects the cloud out, but the AI helps them to take the decision and through this data and make the human like decisions so that the car can detect car can also act in the various robust conditions also. Path planning, which is the one of the major part of the self-driving cars. Without destination, one can't go where he want to do. So It is there are the three parts of path planning. First is route planning, means where the self-driving car want to go. Second is the behavior planning, means decision making, then what to do in the given situation, that we have to stop when the traffic signal is red, we have to slow down the car when the bump is ahead. This can be satisfied by the technologies like finance state machines or decision trees also. Third is a motion planning. Means it's a local path planning. It is used for the various weather conditions or the conditions of the road. Means it helps the self-driving cars to plan that path according to the road condition. If the road condition is very good, then there is nothing to plan. But if the road condition is very bad, what vehicle has to do in such conditions. It helps into take such like decisions. These are the this is the flowchart that how the self-driving car paths their planning. Control system. It is the all the summations of the all the all the four key system and gives and one output to the vehicle. Generally, it controls the whole vehicle motions and actions of the self-driving cars according to perception, localization, path planning, and navigation. And so that vehicle can not do anything or there if there and there should be no breach in the vehicle action or behavior. 3D object detection. It is the one of the most important one thing and key concept of the self-driving cars. The 3D object detection is a crucial part of the autonomous driving. It identifies the 3D environment and utilizes the cameras to create an object and surrounding, enabling to make the informed decisions and about navigation, obstacle avoidance. This system can be broadly categorized into LiDAR-based and camera-based and multimodal approaches. LiDAR-based approaches, where we had discussed above in the LiDAR that it uses the point data cloud and detects the surrounding atmosphere and object movement. Camera-based detection, it utilizes the 2D captures and the 3D object detects perform the using technical depth, intimation, and stereo matching. Multimodal fusion means it has multiple sensors such as LiDAR cameras to leverage the strength and for each set overcome their individual limitations and more provide more accuracy. This is the how the 3D object detection that LiDAR using LiDAR generates the various pulses that bounce back the object and point data forms a point data cloud or around the of the object and this can help the then this and camera help and this camera data help and do the multimodal fusion and helps the self-driving car to do to work. Connectivity integration, that is one of the most part of the connect the self-driving car or if the it is generally a play in develop crucial in the play the crucial role in the development of and functionality of the self-driving car by enabling the powerful data processing and real-time decision making and continuous software updates, because without software we can't control the system. Safety and redundancy and a failure of over failover means the safety is the priority of all the self-driving cars or car companies because human safety is most preferred in the automobile industry. For the safety, the safety is refers to the duplication of critical safety. They do the duplication of critical system and component and ensures the continued operation in safety even if one system is failed. Else and this approach refer to the fail operation or rather than the fail safe means it develop the various algorithms. If there is an failure in the detection of the sensors or in the any algorithm, there will be a breach. It will generally revive that algorithm with another algorithm which is called fail safe algorithm. This is a one of the most key feature in this. So conclusion. And the conclusion behind is the self-driving cars have represent a groundbreaking advancement in the transformation, blending the artificial intelligence, AI, machine learning, and sensor technologies to create a vehicle and capable of perceiving their environment, making and driving decisions without the human input. They promise the safety, increase the safety, reduce the traffic cognitions, and enhance the mobility and a greater efficiently in the fuel and the time. In this way, it is a one step ahead to collaborate and cooperate with the new and advanced technologies in the world. It is the one step ahead to the uh, to the future of the nation and the world. Thank you. Thank you for watching my video presentation.